if today's the 12th. So if a graph looks like this, only this is a local maximum and only this is a local minimum. These cannot be local at the endpoints of the interval.
Well, mine goes like this, like an N. That's why.
So the endpoints cannot be locals.
No, they can be absolute. So in this case, this is a local minimum, this is a local maximum, and this is a local maximum, nothing else.
So how would you write it if the two local max are equal?
I would write when x equals -2 and when x equals 2, local max is y equals 1.75.
So we could have picked any point.
You have to present both for the local max. There are two local max. One exists on the left-hand side, one exists on the right-hand side. It happens that they have the same value. Yes. Anything else? So let's go through the first question. Does the graph represent the graph of a function? Yes, by the vertical line test. Is that okay? Okay, the second one, the domain and range. Was that okay? The domain for the yellow is between 0 and 20. And the range is between -7 and +7. Is that okay? The local maximum. Is that clear? So local maximum is, for this function, obtained when x is 5, and the local maximum is 7. For the local minimum is when x is 15, and the minimum is -7. And increasing between 0 and 5 is increasing. And between 15 and 20 is increasing. Okay, I think we should talk about it. Because
How did they use bracket for? Because I thought it included.
for the trend is always open.
Okay.
The trend is always open.
I think our local minimum is -7.
Find the local maximum values and the x values for which the maximum occurs. Find the local minimum value and the x value for which the minimum occurs. Okay, so yes, please.
So when you wrote on, I have the white one, you wrote find the x-intercepts when it's approximately -3, 3. Why is it in brackets and not?
What is it?
The x-intercepts?
How did you write? -3, 3? You can write that. That's a point. -3, 3 is a point, but you're looking at 2 points. So if you want to write x equals -3, x equals 3, and that was not good enough. Also, x equals 0 is an x-intercept. You cannot write this. Because if you write this, it means everything between -3 and 3, including -1 and 0 and 2.3 and 2.9 and 1.9. You can't do that. You can use braces and say this, but you're missing 0. You could. You could have said x-intercepts are in the set -3, 0, 3. But if you use this, this is a point. This is the point -3, 3, and doesn't make any sense. Good. Anything else?
Over J and K.
Yes. Yes. Find the x. Which form is that? The yellow one?
Yes.
So find the x values for which f of x is -3. So the graph was like this.
That was a -4. Oh, the yellow copy.
F of x equals -4. -4.
Yeah.
-4. I'm sorry.
Uh-huh.
Yes. So f of x equals -4 means y equals -4. I see 2 values or just one? 2 values. And I have to read the x value. f f of x equals -4. I read 12 and I read 18. So here is 12 and this is 18. Is that okay?
Yeah.
That's okay.
I mean, I had the right idea, but I guess the numbers, the 0.5 or something.
It was difficult to read.
Yeah.
I'll take a look at it again. If I made a mistake, I'll give the points back. And I apologize.
That's fine.
Anything else? Other questions from
So
the?
what's K?
Okay, find the values of x for which f of x is greater than 0, between 0 and 10. It's greater, it's on above the x-axis, so this is the positive side, 0 and 10. So the function is positive, being above the x-axis, for x between 0 and 10. And it will be less than 0 between 12 and 20. Anything else? Other questions for me? Other questions? Anything else? So this is what we looked at last time. We looked at solving equations that are quadratic, rational, other types of equations, polynomial, radical, equations with rational exponents, equations that are quadratic in form, absolute value equations, solving for a letter, linear inequalities, absolute value inequalities, and that's pretty much what we did. And we started chapter 2 with symmetry. We said there were two types of graphs, and we just looked at the relationship between f of negative x and f of x for an even function, and f of negative x and f of x for an odd function. Any questions from me? Anything from what we just looked at? Tim, go ahead.
No or absolute value inequalities.
Yes, please give me any example. Yes. Any example, anything you worked on, anything you would like to look at. Any problem? Anything you worked on. Or if you want me, I can make one up.
Make one up.
So absolute value inequality, less than or greater than. Okay, so let's say 1 minus 3 halves x in absolute value greater than or equal to 2. What type of inequality is this? Good, it's an absolute value inequality. So now I have to think. I'm thinking. I'm trying to find numbers whose distance from 0 is 2 or more.
2 less than -2.
Very good, excellent. So there are two options. 1 minus 3 halves x greater than or equal to 2. Or, if you remember the union, 1 minus 3 halves x less than or equal to -2. Perfect. That's the idea. Yes?
Do you know when we use the other U? Did we go over that? When we use the upside down. What is that?
The intersection.
Oh, the
Yes, the intersection is used for the other one with less than or equal to, but since we already perform it without really performing it, we are not writing it.
Okay.
So we go right ahead and say between this and this.
Okay.
But actually, you're right. This is what we're doing. We're intersecting two intervals. Any questions here? Is this clear? Okay, so now remember, I'm making a point. You don't have to do this. I can solve this. But once I change it into these two, solutions of these two with a union in between will be the solutions of this. Okay? So I subtract 1. So negative 3/2 x greater than or equal to 1. And now I want to get rid of this. What should I do to both sides to get rid of that?
Which one?
Multiply both sides by?
Two.
Let's do it in one step.
2/3,
Negative 2/3. Awesome. So I multiply this side by negative 2/3, and I multiply this side by negative 2/3. What do I have on the left? Exactly what I wanted. What did I want? Exactly. That's all I wanted. I wanted x. And now the right-hand side is? Say it again.
negative 2/3.
Awesome. Now I have to stop and think.
Have to switch.
Thank you. Why? Because we multiply both sides by a negative number of an inequality. So I do the same thing for the second one. Negative 3/2 x less than or equal to negative 3. Now what do I want to get rid of? The same number. How do I get rid of it?
Multiply by
So negative 2/3, negative 2/3. What do I get on the left? Well, the answer is exactly what I want. And what do I want?
X.
Perfect. What do I have on the right? I'm multiplying two negative numbers, yes?
6/3.
I'm multiplying two negative numbers. So first of all, it's positive, and then I simplify. I don't multiply before I simplify. The answer is awesome. And now I have to think again. Wonderful. The symbol. Good. So now I know the answer has to have the union. Because it's that type. It's the outside. So the solution has to have the union. What do I write on the left?
2/3.
Negative.
Perfect.
Negative 2/3.
Perfect. With a bracket because of the equal symbol. Then union. Very good.
Two.
Comma. That's it. Awesome. I know who studied. I know everybody else did too, but one person answered today on this problem. Good. Anything else? Anything else for me? Anything? Anything else?
Why can't you just put like the answer greater than less than and the x in the middle? Greater than less than the number.
Because the translation for this is different. I'm trying to find numbers whose distance from 0 is 2 or more. I'm not asking, or I'm not asked to determine 2 or less. Does that make sense?
Can we do another one?
Say it again.
Can we do another one? Another problem?
Like,
Same, but with a little bit more to it.
something
Give
you
an
work.
example?
I'm sorry?
I said, do you want me to give you an example?
Yes?
Absolute value of 4 minus 2/4. And then, so that's absolute value of that minus 1 greater than 2.
I don't have anything to solve. There are no variables. I can't solve this. I can only tell you if it's true or false. So 4 minus 1/2
Oh, I'm sorry.
is
I meant
3.
X. I'm sorry, I meant 2/4 X.
Okay, so that's 4 minus 1/2 x in absolute value greater or equal to 3. So there are two options. Which are the two options? Can anyone tell us?
Minus 1/2.
Yes?
greater than
Good?
4 minus 1 less than.
Very good. And you can take it from there, solve them, and put the union. Is this better?
Yeah.
Very good. Okay. Any questions for me? Any questions? Back to page 252. We're continuing with graphing, piecewise, defined functions. Graphing, piecewise defined functions. First of all, what do you think a piecewise defined function represents? It's a function defined in, that's it. Have we looked at one before? Have we looked at one before? Have we graphed one before?
Probably not the gravity.
We looked at some graphs just to make sure. Okay. So before the class last Monday, we had a lot of questions. We looked at functions. We looked at domain and range, local max, local min, and we answered these long problem, right? Similar to the classwork. Yes. So we did not look at the graph of a piecewise defined function. So now I have a question for you. Is there anything from real life situation that will require a function that is defined in pieces? Meaning, for x between 0 and 2, there is a graph. For x between 2 and 5, there is a different graph. Just for that piece. Between 5 and infinity, a totally different graph. Will we ever encounter something like this in real life? Can anyone give us an example of a real life situation that is something similar? Awesome. Telephone plan. What else? Meaning, if we use between 0 and 1,000 minutes, we pay $20 a month. If we use between 1,000 minutes and 3,000 minutes, we pay 2x plus 5.
Pretty much anything to do with contracts.
Depending on, if you buy in bulk, that's a different function that will give you a discount.
Only certain deliverables or certain dates.
Very good. Here's another example. I have no idea what the tax code moving forward. I have not listened. I have not read. I don't know what it is. But in the past, for someone making between, I don't know, $50,000 and $60,000, there is a function that calculates the taxes that that person has to pay per year. I'm just making numbers up. Between $60,000 and $80,000, there is a different function a different formula that gives the taxes that that person who makes between 60 and 80 is paying, and so on and so forth. Okay? It's a piecewise defined function. So let me make one up, or I can let you choose on page 252. Those piecewise defined functions are between 59 and 70. So let's see how we graph a piecewise defined function. It's not a difficult situation, but it's not a trivial one either. Would you like to choose, or I will? Okay, 64. F of x equals x plus 2 if x is less than negative 3, and it's x minus 2 for x greater than or equal to negative 3. Is this a piecewise defined function? Is it defined in pieces? How many pieces does it have?
2.
Two different functions. One is x plus 2 and the other one is x minus 2. Let me make it a little bit more interesting. I'm gonna put a negative in here. So it's no longer 64. I changed it to make it more interesting. Okay. What do we have to determine every time we are asked to graph? So the question here is asking us to graph. Graph this function. What do we have to determine anytime we're asked to graph a function? What is the first thing, the first thought we have?
The domain is
Thank you. So please bear with me and change this into an interval notation. The interval notation for this is?
Negative 30. Negative 3.
Very good, awesome. The interval notation for this one is?
Negative 3. Infinity.
With a bracket. Very good. So let's identify the domain. The first branch, or the first function, covers between negative infinity and negative 3. The second one covers negative 3 to infinity. What will you conclude about the domain of f? I'm not talking about the domain of x plus 2. I'm not talking about the domain of negative x minus 2 because I have them here. I'm talking about the domain of the entire function. Do you all agree with negative infinity to infinity? Yes or no? Perfect. So that's how I start. Here's my chart from negative infinity to infinity, and this is f of x. Which is a key x value here? Absolutely key, and why?
Negative 3 is
Why? Why is negative 3 a key? Exactly. So I have negative 3. 0 must be in the chart as well. So negative 3 is the key. Now, please pay attention for a moment and hold your questions, and I will answer your question in a minute. So you see, this is a parenthesis facing this way. I'm going to write it immediately after under negative 3. This is a bracket facing this way. It's going to touch the parenthesis facing this way, so this is the bracket facing that way. And both of them are immediately under negative 3. Why? I'll explain in a minute. So please tell me, which function will you use for x values between negative infinity and negative 3?
x plus 2.
Awesome. Which function will you use? I know this is an overkill. I have them right there. I'm looking at them. I want to write them one more time.
Negative x minus 2.
Very good. Awesome. What type of functions are these? Rational, quadratic, absolute value, radical, linear, of course. So let's determine another value here. Give me another value in this territory.
1.
You can, because 1 is not between negative infinity and negative 3. You can. Negative 2 is not between negative 4 is good. So let's plug it in. Please plug in negative 3. And you should say no. You should say no, right?
Not infinite.
Right. However, if you say no to my request of plugging in negative 3, then you have to plug in negative 3.0000000000000000001. So bear with me and plug in negative 3. How much? In a minute. I'll explain everything in a minute. So please bear with me and plug in negative 1. Correct. I completely agree with that.
Negative 1.
Negative 1. Right here inside the parenthesis. So please plug in negative 3 on the other side, please. One more time. Please plug in negative 3 in here.
1.
Thank you. Please plug in 0. Very good. And that's good enough. Okay. So now please from left to right. I know I haven't answered your question just yet, but bear with me. Let me finish, and I'm pretty sure you will answer your questions yourself. So from left to right, which ordered pair will you tell me to plot first?
-1.
From left to right, which is the first ordered pair? -4, -2. 1, 2, 3, 4. 1, 2. This is the first ordered pair. The next ordered pair, please, from left to right. -3, -1. What type of point is this? Is it a full point or is it an open point? Because that does not exist. Very good. The left branch cannot be extended to the right. This is it. Now the next ordered pair, please. Did you answer already your questions, or do I have to explain?
Explain.
Say it again. -3, -1 doesn't exist. It's an open point.
So it's a notional mark.
It's an open point. It's a point that is empty inside, which says that this function gets extremely close to it. I don't have a number. I cannot determine which number is the closest to -3 on the left. I don't have that capability. Nobody does. So therefore, I have to plug in -3 and leave it open. It's as close as possible to that point, but not the point itself, because it's a parenthesis. Okay, on the other side, -3, 1. Is it a full point or an empty point? Yes, because of the bracket. So this will be a full point. You understand that if you put both full points, this will not be a function by the vertical line test. So one exists, the other one doesn't. Okay, and 0, -2. I should, so for 0, -2, I have, yes. So what will be another point that I should put in? What are the x values so I can cross decently the x-axis? No, -2. -2 with minus in front is 2. 2 minus 2 is 0. This is the graph of function f of x. Now, can anyone identify the range of this function? -∞ from the lowest y value to the largest y value, which is 1. Very good. Any questions? I think we should work on another problem. Any questions here, please? Any questions? Is this okay? Yes, please, Marcus.
Why are the points on the red line not, like, why are they not filled in? Why are they filled in instead of open?
You mean this line?
Yes.
-3, 1 is a full point. Everything else in the middle is a full point. I'm graphing this function.
Oh, okay.
This is a continuous function. It doesn't have gaps in it. But I cannot extend it on the other side. Otherwise, it would have been this. But I'm not allowed to extend it because that's the point I'm making here. This function is only between -3 and infinity. This function is only between -∞ and -3. So the purple cannot be extended to the right. The orange cannot be extended to the left. If I do that, it will be a terrible mistake. Is this a function? No. By the vertical line test, it's not. Is this a function?
Yes.
Yes. By the vertical line test, yes. It is. Very good. So let's look at another problem. Would you like to pick or I do? Which one?
Okay.
Okay. So let's pick 70. Okay. We have not reviewed how to graph quadratic functions, but that's okay. So f of x equals 0, 4 less than -3, -x for negative 3 to 0, and x squared for x greater than or equal to 0. Very good, good pick. What type of function is this? This function is a piecewise defined function. How many branches does it have? Very good. So we're going to have 3 different pieces, and they will not be extended. They will not pass the threshold left and right. 1 piece for this, 1 piece for this, and 1 piece for this. Okay? Very good. I need to establish what first? Very good, awesome. Can anyone give us the interval notation for this? It shouldn't take that. Yes, it shouldn't take that long. Anyone should give us, somebody should give us the interval notation for the middle part.
-3.
That's not enough.
And 3.
That's not enough. Negative 3
is 0 and infinity. So
that's not enough for this. You're not telling me this. You're not translating this by simply saying that.
over you.
Oh, with the square bracket on the left.
Open bracket.
Parentheses.
Yes, now it's the same thing. Good. And for this one?
0 positive with the square.
Good. Now I have to look at 1, 2, 3 and decide the domain. So what is the domain? Do you all agree? There is nothing missing? It doesn't always happen. Chunks of the real line may not be there. It happens that we picked 2 problems with all real numbers. Good. So I have all real numbers, which x values must be in the chart no matter what.
-3 and 0.
Absolutely. Why do we have to put -3 and 0 no matter what?
As part
Because this is what happens there is this. I'm in one interval and I jump in the other one. Right? That's a crucial point. Perfect. So now please tell me the symbols under -3. Facing left.
Bracket.
One more time, facing left. Parenthesis. Facing right. Touching because there is nothing missing. Under 0. Facing left. Awesome. And on the other side,
Bracket.
touching. Awesome. Perfect. Remember, it's better to have them in front of you. These may not be presented to you in the correct order. So this saves us from making a mistake, prevents us from making a mistake. Okay, on the first interval, which function?
0.
0. On the second interval, which function?
-x.
On the third interval?
X squared.
Perfect. Clear? Good. So what function is 0? What type? It's a linear function. Y equals 0. Linear function. Good. So let's say -4. When x is -4, how much is y? That's it. When x is -3, and you should be appalled, right? You should say no, but you know why we have to plug it in. So when x is -3, how much is y? That's it. Done. First branch is done. I'm in the middle now. Please plug in -3. Very good. Awesome. Please plug in 0. Awesome. You shouldn't. You should say no, right? But we know what we are doing. So let's plug in 0 on the other side. Let's say 1, and maybe 2, because it's quadratic. It's not linear. So plug in 1 plus. Please. Plug in 1, please. 1. And plug in 2, please. 4. Good. Ready? From left to right. One more time, these piecewise defined functions appear difficult. Once you understand them, it shouldn't be. From left to right, what would you tell me to plot? Perfect. Full point, of course, it's in the middle. -3, 0 is the next point. What type of point is it?
Open.
Awesome. Look what I do now. That's the piece where y equals 0 from -infinity to -3. Perfect. Next ordered pair, please. What type of point is this? Full point. Very good. Then 0, 0, what type of point is it? However, because this is the same number, it doesn't matter. Only because there is no jump. They are the same. Good. Next order pair on the other side is 0, 0, and the next one would be? Very good. It is indeed 1, 1. And then the next one? That's it. But remember, this is a quadratic function. It's not a straight line. Perfect. I only want the range, and we can move on.
So, excuse me, but the reason the origin had the point at a solid is because it actually, even though it's a open parenthesis on the left and right sides of race, so
Only because these two are the same number. Here they are not the same number. So obviously this will be an open point and this will be a full point.
even though it satisfies two equations.
So exactly. So this will be an open point. But then on the other side I have to start in here. So I have to fill it in. Because it's the same number. Perfect. Anyone can give us the range.
0,
Perfect. From the lowest y value to the largest y value. Perfect. Any questions? Let me continue and then we'll come back at the end and do more and more. Because I need to talk about the difference quotient. Okay? Let's see what this means. Two impressive words, right? No, not at all. So let's take a look at a function. Here's my function f. And I'm going to pick a point. I'm going to pick this point x. And what is the y coordinate of x? If this is x, you cannot say that. This is a point on the graph. So if this is x, this must be, or, perfect, or there is another way of saying y. Perfect. That's all I wanted. So the coordinates of this point, I'm going to call it A, are, can anyone dictate them one more time? Comma. Very good. Perfect. I'm going to say that this is point B. And I'm going to say that I am increasing x by a quantity called h. I'm adding h to x. So what is this now? Perfect. Awesome. Thank you. And then I want you to tell me what this is. Careful. Let's write it here first, and then we'll write the coordinates of B.
f of x plus h.
Thank you very much. Is this clear? So now can anyone, for reinforcement, can anyone give me the coordinates of B one more time? No, we start with x. Oh, of course. Forgive me. I'm daydreaming, sorry. My apologies, my apologies. Sorry, sorry. Okay, perfect. X plus h, comma. Sorry about that.
Functions x plus
For some reason I heard f. Sorry. Good. So I have point A, I have point B, and now I would like you to give me the slope of this line. How is the slope denoted? No. I want to know the notation for the slope first.
X1.
The notation is, yes. The notation is, what letter we use for the slope?
and
Very good, awesome. And then now,
y
very good. Yes, over. Perfect. All I want you is to mimic this for the points we have. That's all I'm asking you to do for me.